Okay, so remember last time we looked at an example where it fit factored form or intercepts form. This is on the second test, chapter 5 test, the quadratic functions non-graphing calculator test. So here's an example, a little different. Which form does this fit? And look what it tells you. It says, write the quadratic function in vertex form. The vertex and a second point are shown. What form are you going to put this in? Vertex form. Okay, where's the vertex? Which of the 2 points, top or bottom? Top. So there's the vertex. And the coordinates of the vertex might be hard for you to see, but it looks like it's over 6 and up 4. Okay, so what is vertex form? A times the quantity x minus h squared plus k, right? We just want to plug in values for a, h, and k. Okay. So which two do we know right now? H and k. Those are the coordinates of the vertex, aren't they? So we're just going to plug 6 in for h, 4 in for k, and we're 2/3 of the way done. Right? At that point, we've got y equals a times x minus 6 squared plus 4. How do we solve for a? Yeah, we're going to use the other point. The other point is on the curve, and so it's a solution. In other words, it tells us, if we look at the coordinates of this other point, it looks like in this case they are over 4 and up 0. So that's saying, in other words, when x is 4, y has to be 0, right? So if I plug in 4 for x and 0 for y, I'm going to get a really simple equation that I can use to solve for a, right? So what's that give me? All right, so if we do that, we're going to get 0 equals a times the quantity 4 minus 6 squared plus 4. And now all we're going to do, we're going to simplify this first of all, right? So we have to just follow normal order of operations. So what do? What's 4 minus 6? Negative 2 squared 4, okay? So I get 0 equals a times 4, right? Plus 4. Now, the most common mistake that I saw from people is they wanted to add those things up, but I can't do that, can I? The a is being multiplied by that first 4, so I can't add it to the second one, because the second one is not being multiplied by a, right? A better way to think about this, I think, is to maybe take one more step and rewrite this. What is a times 4? 4a. Good. So we'd want to really write this instead like this. 0 equals 4a plus 4. Now, what are the 2 steps in order to solve for a? Subtract 4 and divide by 4. Good. So then we'd end up with negative 4 equals 4a, so a equals what? Negative 1. So all we have to do then is go back up here. Now look, this was the point right here where we had 2 out of 3. All we needed was a, right? So if I just plug negative 1 for a, I'd have my answer. So what's that going to look like though? We got to be careful with this because we got to write this in simplified form. So technically we've got y equals negative 1 times the quantity x minus 6 squared plus 4. But do I write a negative 1 there? What would I write instead? Just a negative sign implies the negative 1, doesn't it? That might seem like a minor thing, but that's in algebra, those kinds of things end up being more important as you go further down the road. Okay? So that's it. Make sense? Okay, let's look at maybe another one on here that seemed to be a little problematic was is this one that I wanted? Yeah, this one. Okay. darn it. Probably the most commonly missed question on the test. And I get it. I mean, this is kind of a hard one, but it's not terrible. Okay, so if we want to put this into vertex form, what form is it in right now? General form or standard form? Good. We want to put it into vertex form, and you already told me what that is. Y equals A times the quantity X minus H squared plus K. And the part I really want you to see here is, remember, that's a perfect square, right? So to get a perfect square out of this stuff over here, we have to complete the square. That's the algebra way of doing that, right? And so our strategy is pretty straightforward. Let's write this f of x as a y, first of all, just so the algebra looks a little easier. So we start with y equals x squared plus 8x plus 32. Now, completing this square, remember, let's just review this process really quick, because I'm not going to give you any really hard ones. I'm giving you only a pretty simple one in a way. You don't have to do an awful lot. If you want to complete the square with these two terms right here, the relationship that we have is this one. We know that if I ever have x squared plus some number times x, call it b, right? Could be negative, could be positive. The way that I'm going to get a perfect square out of this is by adding what number? Just in general, in this case, you're right. And the one up here, you're exactly right. In general, what would that be? Half of b squared. Good. Whatever the number is that's being multiplied by x, as long as we have a 1 in front of the x squared, we're just going to add half of that number squared. Okay, and what that gives us then is the perfect square, x plus half of that number times itself, or squared. And that's our goal, is to get a perfect square, isn't it? Right? So for our problem up here, our b is an 8, isn't it? Right? So, but before we get there, let's just get rid of this. Let's chase that 32 away from that side so it's not bogging things up. We'll just store it on the left side. So we'll go y minus, oops, 32 equals x squared plus 8x. And then so what's our b? What's our b? 8. So what number do we add here then? 4 half of, good, half of b, which is half of 8, which is 4, squared. Okay, and I have to do the same thing to both sides though. So on the other side, I also have to add 4 squared. Right? Now, why did I do that? What does this side become then? The whole point of that was so I could factor this into a perfect square, something times itself. And if you multiply that out, you're going to get x squared plus 8x plus 16, and the magic numbers are really obvious. Okay? What's that going to be? What perfect square? X plus what? 4. That's it. Quantity squared. Okay? Make sense? And if you think about that, it has to be that way. If I FOIL this out, the first term times the first term has to give me x squared, right? So that squared has to be x squared. The last term times the last term has to give me 4 squared, or 16. So it's got to be a 4, doesn't it? Right? When I FOIL this out, and that's always the pattern we're going to follow. It's that way every time. You just got to know that pattern. So meanwhile, on the other side, what have we got? Y minus 32 plus 16 is what? Yeah, y minus 16 equals all this stuff. My x plus 4 quantity squared. So what do I do? Add 16 and we are done. Okay, that's it. It's in vertex form. Okay. All right, maybe we have time for one more. This would be a good one, I think. Oh, darn it, did it again. Okay. Okay, so what about this? Very, very simple question. All they want us to tell here is two simple things. The discriminant has a, oops, I can't pull that down. Our only choices are positive, negative, or 0. That's all it's at. It doesn't even want the exact value, just positive, negative, or 0, which tells us that the quadratic equation has 0, 1, or 2. Those are your only possibilities, 0, 1, or 2 real solutions. Okay? So how do we do this? What is the discriminant? That's it. It's the part under the square root in the quadratic formula. And remember the quadratic formula. There really are two parts to the quadratic formula. It's not just x equals negative b plus, it's not just that stuff. It's also, you have to start with ax squared plus bx plus c equals 0. If you have a quadratic equation in standard form, so it's set equal to 0, if that's true, then we know that x equals negative b plus or minus square root b squared minus 4ac, all divided by 2a. But it's the square root, remember, that's deciding a lot of stuff about what we're going to get for our answers. If the square root, if we're taking the square root of some positive number, what's the square root of 4? 2. What's the square root of 9? What's the square root of 25? What's the square root of 22? Who knows? But it's, would you agree it's going to be some positive decimal, some positive number? What's the square root of 117? Who knows? 10 point something though, right? It's going to be some positive decimal number. So if I'm putting a positive number inside the radical, I am going to get back how many real solutions? 2. 1 for the plus, 1 for the minus, right? I'm going to get negative b plus whatever my square root number is, all divided by 2a, or negative b minus whatever my square root number is divided by 2a, right? Now what happens if the number under the radical just happens to be 0? What if the discriminant happens to be 0? What's the square root of 0? 0. Okay, so what's negative b plus 0? Negative b. What's negative b minus 0? It's the same answer, right? So if the discriminant is 0, I get one solution. Real quick, last case, what if it's negative? What am I guaranteed to get? I'm getting i's, aren't I? So I'm getting no reals. They're going to be imaginary. All right. Good. One more session. I think we're good to go on this one.